Good morning, ladies and gentlemen. You are welcome to another edition of our class. The course code is M8121 and the course title, Algebra and Coordinate Geometry. And the topic of discussion is binary operations. We look at binary operations. We started it our last class. I explained what binary operation is. The word bi means two. So we are looking at two elements of a set, and then you perform a particular operation on the two elements. Whatever the outcome is what we are discussing. And we said that the outcome will result to any of the following property: closure, commutative, associative, existence of identity, existence of inverse, and lastly, we have distributive property. In our last class, I only explained each of these properties. I explained it up to number 4 using our usual operation: addition, subtraction, multiplication, and division. So I explained all this. And I did mention that as far as binary operation is concerned, we are not going to be particular about those operations. Addition, subtraction, multiplication, division, of course, yes, it will form part of our question. However, a specific operation will be given. It will not be predefined. Like we have 2 plus 2 equals to 4, 3 times 9 is 27, and the rest. No. And I strongly advise that you work with the definition of the problem whenever you are given. Let me remind us again that I said in closure that when you pick two elements of a set, the specific operation is performed on the two elements. If the final answer is from the set, then we say that the set is closed, and that is closure property. If the final answer is not from the given set, then it is not closed. We look at commutative, that an operation is commutative if when we perform operation, the first element on the second element is the same thing as second element on the first element. And I said that the way you perform operation is immaterial. As far as commutative is concerned, we must always get the same answer. Whether the first element starts the operation or the second element starts the operation, the two must give us the same answer. Similar thing goes with associative, that we are dealing with one operation, 3 elements. However, we can only take 2 elements at a time. We cannot take the 3 elements together. Then the operation will be performed twice. The first 2 elements gives a specific result. Then you take it back to the third one to give another result. The way you arrange those elements is immaterial. Also, under associative, we must obtain the same result. What we mean is, we have A operation, B operation, C. The result must also give me A operation, B operation, C. Here I perform this operation first. Here I perform this two first. Then whatever we have becomes the final answer, and they must be equal. Very, very important. Identity. I use our country, Nigeria, to explain identity. That what makes us unique, what makes us stand out, is our identity. Anywhere in the world, I use our passport, the green passport. Anywhere we see green passport, we will not be told that that is in Nigeria. I use our currency. Anywhere we say now the currency is being changed, the 1,000, the 500 naira, and the 200. Anywhere in the world, we take the old one, they know that no. We are no longer using it, and this is the new one. Anyway, we take our currency to it identifies us as Nigeria. Same thing with our coat of arms, that is the sign to identify our national anthem and the rest. And from there, I moved down to the region individually. How do I identify that this man is an Igbo man? I use a case study. Yoruba man, I use a case study, and Hausa. That you need not be told some certain things are peculiar to all of us as ethnic group. The moment you see that thing, you should be able to tell this person is from this region, this person is from this region, without the language. The way we dress, sometimes, the way we eat, sometimes, the type of food we eat defines us. These are identity. It doesn't change. No influence. You cannot influence identity. You can't. You can't. Take for instance, Banga is from eastern part of the country. Abacha as a food is from eastern part of the country. So that cannot be changed. You don't have anybody from that region does not have influence. Bure, for instance, is from Yoruba. Ewedu is from Yoruba side. Nobody can influence Tuo, Chikavi, Fura. These are things we cannot influence. And that takes us to the typical type that we have in mathematics. And I said in mathematics, an identity element is an element that has no influence on other elements. It doesn't change other elements. For instance, we take addition as a case study. We said 0 as an identity element does not have influence on all other numbers. 0 plus 1 is 1. 0 plus 8 is 8. 10 plus 0 is 10. Minus 8 plus 0 is minus 8. It has no influence. And for multiplication, we talk about it also, that when you have 1 is a multiplicative identity. When you multiply any element with 1, you get that element. 1 has no influence. 1 multiplied by 10 is 10. 1 multiplied by square root of 8 is square root of 8, and so on and so forth. So today's class will be more of problem solving. We take questions, we answer them. How do we set question as far as the binary operation is concerned, and how do we answer this question? Once again, you are welcome to today's class, and it promises to be interesting and more informative. So let's start with the first one. Closure property. Let S be a non-empty set, on which a binary operation say aesthetic, not necessarily aesthetic, is defined. Full stop. S is said to be closed if for A, B member of S. That is, you pick any two elements in S, our A operation B is also member of S. Full stop. So let's take 1, 2, 3 push. Example. Let's number 1, consider the binary operation. Binary operation, dotted circle, defined on the set of integers by P operation Q equals P plus Q minus PQ is the set closed under the binary operation. The binary operation star. Question mark. Let us discuss. So let's discuss. Copy what you have on the board. Then let's discuss. Can I start the discussion? If yes, type yes. If no, type no. Use the chat room to answer that question. Can we start the discussion? Okay, some people, okay. Let me give you 1 more minute. Those that are saying no, quickly copy what you have on the board for 1 minute. I haven't seen Peter Holly in the class. I hope all is well with him. Okay, let us start the discussion. In that question, the first thing we need to underline, oh, sorry, the operation is a dotted circle. Change this to dotted circle. Dotted circle. That's the operation. Now, the important part of this question is this. We are working on the set of integers. Then the operation defined is this. And finally, the definition of that operation is given thus. As this. So we need to analyze. You don't have to substitute number. You just need to look at this, picture it out. And then I will explain with what you know. Let me start with number first, so you can picture it out. The first thing, integers. What does it mean by set of integers? What does it mean by integers? Yes, anyone? Set of integers. What are the set of integers? Anybody? I will call names now. Let me start with someone claimed not to have seen what is on the board clearly. Is that same to everyone? Is it the same thing to everyone? Or the John? Yes, sir. You cannot see what is on the board very well. How come? Okay, I will increase the font of my handwriting. I will increase the font of my handwriting. So let's discuss. So what are integers? Integers. Integers. Yes, what's the set of integers? No one is answering. Aja Koren officer. Okay, somebody has raised hand. Benedicta. Kindly unmute yourself, please.
Integers contain positive and negative whole numbers.
Positive and negative whole numbers. Thank you so much, Benedicta. You have 2 marks. Others refuse to answer that question. Since you have answered it, you have 2 marks.
Sir, I typed that before.
You do what?
I typed that before, even before Benedicta.
I did not see it. I did not see it. Yeah, I'm just seeing it now. All numbers, including negative numbers. No, this definition is not totally correct. So, nonetheless, Quadri, you also have 1 mark. At least you make attempts to do that. Positive and negative whole numbers, including 0, is called integer. So let's start. If I pick an integer, sorry, 2 integers, we add them together. What will be the result? Let's start with that. 2 integers, P plus Q. P is an integer, Q is an integer. Will the result be an integer? Question mark. Yes. Will the result be an integer? Pick any 2 integers of yourself, of your choice, and see whether the result will give us an integer. If you add them together, it can be negative, it can be positive, can pick negative and positive together, add them together, and see whether the result will give us an integer. Does it give an integer? Yes, anyone? That's basic analysis. 2. Yes, 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 yes. I agree. Addition of 2 integers is an integer. Let's take PQ. PQ. I pick 2 integers and I multiply. Will the result be an integer? Yes. Yes. An integer, correct. 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 Now, finally, this result give 1 integer. This result give another integer. And what we have here is subtraction. If I subtract 2 integers, will the result be an integer? Subtraction of 2 integers, does it give an integer? The subtraction, no. This person, Zoom user, kindly unmute yourself, please, and tell me your name. Zoom user, kindly unmute yourself. Zoom user. Kindly unmute yourself, Zoom user. Thank you. Your response to the last question, that subtraction of 2 integers gives an integer, you said no. Can you explain?
So it's a mistake.
It's a mistake. How do you mean?
I mistyped.
So are you saying that if I subtract 2 integers, the answer is an integer?
Yes.
Okay. Ode John, kindly unmute yourself. You put a clause here. John, kindly unmute yourself. Have you done that?
Yes, sir.
You put it here that it depends on the number that I pick. Can you explain?
What I mean is this: what if you pick a whole number, 2 whole number? Let's assume you pick 2 and 7.
Okay.
What if you say 2 minus 7 and it's giving you negative value?
-5, isn't it?
Yes, sir.
Is -5 an integer or not?
It's an integer.
So? Sorry?
Yes, sir. It's a mistake, sir. I understand now.
You understand now? Oh, thank you. Thank
Yes,
you
sir.
so much. Thank you so much. Thank you so much for that. Now, that means that if I add two integers, the answer is an integer. If I multiply two integers, the answer is an integer. If I subtract two integers, the answer is an integer. Then we conclude that this operation is closed. So what we are going to do now is we will say that since P plus Q minus PQ since P plus Q since P plus Q minus PQ gives and what? An integer, comma, therefore, P operation Q is an integer. Hence, the set is closed. The set is closed. Full stop. Question 2. Number 2. Given the set, two, three, four. Define operation triangle. No, given the set, let me define the set. A equals to on A by A operation B equals AB mod 5. Full stop. Is A closed under the operation triangle? Question mark. Is A closed under that operation? Let us look at this question. Solution. Now, the technical part of the problem is this mod 5. What does it mean by modulo? Let me define it. Modulo 5. What does it mean by modulo 5? What does it mean? Yes? Tayo, kindly answer that question. What does it mean by modulo 5? Tayo, kindly unmute yourself.
Okay.
Unmute yourself. Yes.
Okay. So modulus 5 means numbers from 0 to 4.
And number from 0 to 4. And what's
Yes.
the meaning of the AB here?
AB means you are multiplying the two numbers.
And the result must not be greater than 5.
Yes, it must not be up to 5.
Must not be up to 5. Thank
Yes.
you. So what do we do? So we form a table. Our elements 2, 3, 4. 2, 3, 4. So we multiply out. Two times 2 will give us 4. 2 times 3 is 6. That is already greater than 5. So what are we going to do? We must not get an answer greater than 4. Now we have gotten an answer that is even greater than the modulo. What do you think we should do? Anybody, any idea from the house? You did all this in secondary school. Koyum Wasil, kindly answer that question. We have 2 times 3, 6. We cannot record it because it is greater than our modulo. So what do you suggest we should do? Koyum?
Sir,
Yes.
we divide it by 5, then we write the remainder.
We divide by 5, then we write the remainder. Thank you.
Yes.
That means that the answer here is 1. 2 times 4, that is 8. Divide by 5, remainder 3. 3 times 2, 1. 3 times 3 will give us 4. And 3 times 4, 12 will give us 2. 4 times 2 is 8. That gives 3. Upon division, and you record down the remainder. 4 times 3, 12, that gives 2. Upon division by 5, and you have remainder 2. 4 times 4 is 16. Divided by 5 will give us remainder 1. Now let's discuss what we have within this point is our results. Now, carefully look at that result. Can we conclude that the set A is closed, and why? If it is closed, why? If it is not closed, why? Yes? Anyone? Quadri, kindly answer that. Unmute yourself, Quadri.
Yes, sir. It is closer because we still have the same numbers in the set, sir.
It is closed
Yes, sir.
because all the number we have here, they are in the set, isn't it?
Yes, sir.
What is the set? What is the given set?
A is equals to 2, 3, 4.
2, 3, 4. And the element we obtain, all of them, they are in that set.
No, aside 1, sir.
Aside 1. So what's your conclusion?
So that means it is not closer
It is not close. Why is it not close?
because 1 is not in the set, sir.
Thank you. Since 1 is not a member of A, therefore, A is not what? Is not closed under the operation. Operation star. Sorry, triangle. Full stop. Let me stop there as far as closure property is concerned so that we don't waste much time. It's not closed because there's an element in the result that is not in the set. And that element is 1. Let's get to commutative. Commutative property. Let S be a non-empty set on which a binary operation star is defined. Full stop. Star is said to be commutative. Star is said to be commutative if A operation star is same as B operation star. Full stop. A operation B is same as B operation A. Now, you must not take this as A operation B. Rather, take what you have here as first element operation second element. You take it as first element operation second element. That's what you are going to look at it, the angle you are going to look at it from. So I will explain now. But before that, let me first of all give a simple example. Let a binary operation. Let a binary operation star be defined on the set R of real numbers as A operation B equals A plus B minus AB. Let me see use this. That's example 1. Compute. Problem figure 1. 3 operation 1. Problem figure 2. 5 operation minus 2. I will take the first one, you take the second. Solution. I have first element on second element as first plus second minus their product. So if I have 3 operation 1, our first element is 3. We go by definition now. This is the definition of the problem. So it will now be first element plus second element minus first multiplied by second. And that gives 4 minus 3, which equals to 1. Final answer. Problem figure 2, please try problem figure 2 in the next 1 minute, and let me have your results. In the next 1 minute, try that, let me have the results. Okay. Someone said, let me see. That's 10. Okay. Who is this? Afolabi Taiwo. Ayedeju Pelumi. I will get back to you on the answer you write on the chat room. I'll get back to you on that. Others, please, in the next 30 seconds, I will stop you. I skip your name, Anthony. Did you put anything there, Anthony? I'm sorry. Let me check. Oh, Anthony, I'm sorry about that. You are the first person to even answer it. Anthony, I will come back to that. Okay. Some people here that I call their name, Anthony Afolabi, John, Michael, all of them said that the answer is 13. Let us confirm. I have 5 operation minus 2. And that is first element plus second element minus first multiplied by the second. This gives 5 minus 2 plus 10, which equals to 13. And as such, all of you are correct. Those that I mentioned their name, you are 100% correct. So thank you so much for attempting the question. So let's go to another area of still the question. Let me use the question now. Let me use the question. Let me remove this and write that number 2. Number 2. You now say that is the operation star commutative? Question mark. Is the operation star commutative? Commutative. Question mark. Is it commutative? Let's discuss. Before I discuss it, let me use the number, but in the exam, you cannot use number to discuss it. We have 3 operation 1. Let's take 1 operation 3. For instance, 1 operation 3. That is the first element plus second element minus first times second. And we have this one to become 4 minus 3. This may be a coincidence. Let's take the second one. We are going to have minus 2 operation 5. So first element is minus 2 plus second element is 5 minus first element minus 2 times the second element. Minus 2 plus 5 gives us 3. Minus plus minus is plus. 2 times 5 is 10. We have 30. You now see that irrespective of the element that starts, as far as that operation is concerned and the definition given by at the right hand side, we obtain the same result. We obtain 13, we obtain 13, we obtain 1 here, we obtain 1 here. So we can conclude that it is commutative. However, how do we show it? How do we show it? So follow me as I put it on the board so that you follow exactly what is going on. I will show it 2 ways. Way 1, I have A operation B, that is what is defined. A plus B minus AB, equation 1. Now I need B operation A. In this context now, our first element is B, second element is A. I will go by the definition. The definition is first element plus the second minus their products. So our first element here is B plus second element minus the products, equation 2. Now, carefully look at the result, the right hand side of equation 1 and the right side of equation 2. Are they equal? Are they equal? Yes, lot of yes here. Yes, they are equal. Since A plus B minus AB equals B plus A minus BA. Therefore, A operation B equals B operation A. That is one way. Let me call this one method 1. Method 2 is to work from the left to the right. So if star is commutative, so sorry, hence operation star. Operation star is commutative. That's conclusion. If operation star is commutative, comma, then we must show that A operation B is same thing as B operation A. How do we show it? Recall from the question that A operation B A operation B A operation B is A plus B plus minus AB. That's what we have. Now try to change the role of A and B. A operation B, change the role of A and B. Let A take the role of B and B take the role of A. That means that I have B plus A minus AB. And the result gives B operation A. B operation A. So therefore, operation star is commutative. Let me take one more question on that. Number 3. Let a binary operation circle plus, let a binary operation defined on the set of real numbers. Real numbers by P operation Q equals P squared plus Q plus PQ. Or let me say 2PQ. Full stop. Verify if circle plus is commutative. When you get to 200 level, we are going to look at some methods of proof in mathematics. One of them is what we refer to as counter-example proof. The counter-example is to show that one component of what are given is not true. Or you give example straight away that this is not true. Check this out. Let me give you an example. If I claim that every Volkswagen product, I'm talking about vehicle cars now, the product of Volkswagen have engine at the back of the car. That statement is not true and you don't argue. You only need to give example of Passat, Bora as example. Passat and Bora are Volkswagen products and they have their engine at the front of the car, and that's not the problem. Similar thing, when you have a problem in mathematics that seems not to be true, just give example, and that solves the problem. So here, I will give example. P squared plus Q plus 2PQ this operation will not be commutative because of the power here. Suppose there is a powerful cube, there's likelihood that they are going to be commutative. However, the absence of that power 2 here shows that if I replace Q by P and P by Q, that's I change their roles, I will never get the same result. So I will now say that solution. Consider we provide counter example. The moment you say this one in mathematics, we are very sure that you want to show that the statement is not true. We are 100% sure that you want to tell us that the statement in question is never true. So pick any two elements of your choice, any two elements of your choice. Yes, let me have the elements from the chat room. Two elements, okay, two hands are up. Afolabi Taiwo, kindly unmute yourself.
Yes, back to this method too that I used here. You said we'll like interchange it where there is A, we'll put B there.
Yes.
But yeah, you did B plus A minus AB.
Thank you very much, Afolabi. This will be B.
Okay.
Afolabi,
Okay,
thank
sir.
you. 2 marks for that. 2 marks, 2 marks, 2 marks. Thank you. Anthony. Anthony?
Sir, that was what I wanted to point out.
Okay, 2 marks for you also. 2 marks. You have contributed very well in the class today, the two of you. Thank you so much. So let me continue. We give a counter example now to show that. Tayo, kindly unmute yourself.
Yes, sir. That same one that the other person corrected.
Laila, you raise the hand after giving them. You raise the hand after giving them two marks. No, you cannot play that with me. You know me now. Bad.
No, you must be notes. You just have to correct the answer.
You need to contribute more to have that 2 marks.
No, not because of 2 marks.
You have to contribute more. No problem. All the best. Yeah. Take care. John picked 4 and 6. I would have loved 1 positive, 1 negative, but there's no problem. Let me take 4 and 6. Consider, we give counter example. Consider 4,6 member of real numbers. So we take 4 operation 6 first. And that is first element squared plus second element twice their products. 16 plus 6 plus 48. 22 plus 48 gives 70. We also take 6 operation 4 now. Our first element is 6. That is first element squared plus second element plus the product, twice their product. 6 into 4. 36 plus 4 plus 48. And that will give us 88. Since since 70 is never the same thing as 88, therefore the operation is not commutative. Operation is not commutative. Full stop. The operation is not commutative. So that's how we show that it is not commutative. Benedetta, kindly unmute yourself. Your hand is raised.
Please, I cannot see the board very well.
You cannot see the board very well.
Yes.
Which part of the board?
The example you just finished with this one.
Where?
From that 4 operation 6.
4 operation 6. Okay. Let me take it here. Let me take it here. We have 4 operation 6 equals, we go back to our definition. Our first element, sorry, I'm using wrong operation. It is a circle plus. Circled plus. First element is 4 and it is squared, plus second element, which is 6, plus twice their product, 4 into 6. And evaluating, you are going to have 70. Then now take 6 operation 4. The first element here is 6, which is squared. The second element is 4, plus twice their products. Evaluate this, you are going to have 80. We now conclude that since 70 is never 88, sorry, you have this to be 88. Since 70 is never the same thing as 88, then the operation is not commutative. The operation is not commutative. And that's exactly what we. So let me now move to the next one. Associative. And that may likely be where we're going to stop looking at our time. Associative. Any questions so far? Before I take associative, you have question, kindly signify. Okay. Zoom user said that kindly unmute yourself, please.
Sir, my name is Michelle.
Michelle, you have to change it to
Yes.
Michelle.
My name is Michelle. Actually, what I have to say is not about this mathematics we're solving. You asked a question before we started about Gloria, so I want to take an excuse for her. Before.
So any question? If there is no question, let me take associative. Then we stop there today. As far as question and answer is concerned. So our next class, we take the remaining 3 properties. I'll give example. We now take general questions on all this. So still the same way, let S be a non-empty set. A non-empty set on which a binary operation star is defined. Full stop. Operation star is associative. Associative if A operation B, sorry, A, B, C member of S is such that A operation B operation C equals A operation B operation C. Full stop. Let me take 1, 2 examples on this. Then we'll call it a day because of time. Immediately after your class, I have another class. So number 1, consider the set of integer on which the binary operation circle multiplication is defined as follows. R operation S equals R plus S plus 1. Compute. Probability 1, 3 operation 5 operation minus 2. 2 minus 4 operation 7 operation minus 9. Let us take this. Let me take the first one. Solution. No, let me change this. Sorry, let me change the second one to let me change it this way. Yes, so that they won't look the same. So the first one, I have 3 operation 5 operation minus 2. I will take this one first. That's the first thing I will take. And you may also take the two of them simultaneously anyway. But let me take this one first. Maybe next class I'll work on the second one. And it may be this class also. So now, what is 3 operation 5? First element plus second plus 1. First element plus second plus 1. And that gives us 9. So this now implies that 3 operation 5 in brackets operation minus 2 equals 9, because they have calculated this, operation minus 2. Then we move further to define again. Now we're now working on 9 operation minus 2 using the same definition. Our first element now is 9, and our second element is minus 2. And that gives us 9 plus minus 2 plus 1, which is going to be 8. And that is the answer. So copy what you have on the board, try Roman 2. You have just 1 minute to do that. Yes, your response. 16 responses. That's good. Oh, I love these. I always love when I have different answer. Some majority said -4, and one single person said -3. And -3 could be the final answer because in mathematics, majority don't carry vote. One person may just differ in opinion on mathematics, and that person may even be the correct person. And I have another one here for. Let us all discuss what we have on the board. Let's discuss. I think I can rub off this. I have -4 operation 7 operation -9. So now I'll first of all we first take 7 operation -9. And what's 7 operation -9? So that is first element plus second element plus 1. And that will give us -1. But 7 plus 1 is 8. 8 minus 1 is -1. So that now implies that -4 operation 7 operation -9 equals -4 operation. Now we have obtained value for this as -1. First element according to the derivation plus second element plus 1. Of course, -1 plus 1 gives 0, and the final result becomes -4. We are yet to look at how do we verify that a given binary operation is indeed associative. We are yet to look at that, but this is a preliminary stage. So in our next class, we will consider more example on associative. Till that time, I wish you all best of luck. Bye.